So the displacement equation for the particle when it is just moving on the circumference of a circle, we can write it as y is equal to r sin omega t officially. R is radius there, which of course we call it as maximum displacement of the particle. That is what we call it as amplitude here. Therefore, I can write that one as y is equal to a sin omega t. Let us now develop different equations based on that displacement equation. Let us write here, I just take up first displacement. Y is equal to a sin omega t. When displacement equation is given this way, what would be the equation for its velocity? In fact, we all know when displacement is differentiated with respect to time, we get velocity. So, v is equal to dy by dt, which can be written as a omega cos omega t. But when you just look at the basic format of an equation, particularly simple harmonic wave equation, when we consider, there is an orderliness in that equation as such. What is that orderliness? You just look at first. Displacement equation we have written y is equal to, fine. First one, before the function whatever you are having, that is to be called as amplitude. After this amplitude, we will be coming across the function, maybe a sine function wave or a cos functional wave. After the function, whatever we are having here as angle, that is what we call it as a phase. In fact, phase is nothing other than the angle subtended by a vibrating particle from its mean position of rest. The angle subtended by a vibrating particle from its mean position of rest. Let us elaborate that one a little later. So, if you look at this one, amplitude first, then function, then phase. Exactly in the same order, you just go ahead here. Amplitude now becomes a omega. Function is cos function. Phase value is omega t. So, amplitude, function and wave. What is this a omega now to be called? In fact, cos function can become 0 when theta becomes 90. That is what we call it as the minimum value of cos function. Cos functional maximum value is 1. When cos omega t becomes 1, then this itself is going to be the maximum possible velocity of the particle. Therefore, we can write this a omega as either velocity amplitude, that is one way of representation, or you can even call it as maximum velocity. So, either velocity amplitude you can call it or maximum velocity you can call it. What is the formula for maximum velocity of a particle in SHM? That is a omega, where a stands for amplitude and omega stands for angular frequency of the particle. If I just take acceleration of the particle now, acceleration when we want, acceleration a is equal to dv by dt, rate of, that is differentiating the velocity with respect to time, or rate of change of velocity, whatever you talk about, both are referring to acceleration of the particle only. So, when we take a as dv by dt, what is its equation now? Minus a omega square sine omega t. When you just take this equation and study that one carefully, this can even be rewritten this way: a is equal to minus omega square into a sin omega t, which now to be called as a displacement. Therefore, minus omega square y I can write. So look at this equation carefully. Acceleration of the particle in SHM is equal to minus omega square into displacement. Is it not the basic equation what we have taken up earlier while defining simple harmonic motion of a body? So whenever simple harmonic motion we consider, acceleration is directly proportional to displacement in opposite direction. And what is the constant of proportionality there? It is omega square, which of course we can call it as angular frequency whole square. That is the concept. So this is the ultimate equation what we have to remember, and this displacement equation, velocity equation and acceleration equation of different waves like we have to remember. When you consider displacement equation carefully, amplitude of oscillation of a particular body will definitely be constant. As far as a wave is concerned, there will be only one maximum displacement for that, unless it is a damped oscillation or a damped wave. So amplitude remains constant, sine function remains constant, omega remains constant for a particle. But what is a variable here? It is the time. Therefore, when we just plot a graph between displacement and time, then I will be getting a sine functional graph like this, sinusoidal waveform. That is actually the graph what I am going to get: sine 0 0, sine 91, sine 180 0, sine 270 minus 1 and sine 360 0. And what is this particular maximum displacement called here? It is called as amplitude. Whether you take that amplitude in the crust or trough, never mind, it will be the same. So this is the graphical representation for this waveform. If you take the second one here, I just plot a graph between velocity and time this time, because velocity is a variable, time is a variable. Rest of all the things are all constants. So when I just plot a graph, being cos functional wave equation it is, you will be getting the graph like this. So what is going to be the maximum displacement over here called as amplitude? It is A omega. So A omega is going to be the maximum velocity, you can call it, or velocity amplitude you can call it. Exactly on the same lines, when we just plot a graph between its acceleration and time this time. This is acceleration I am considering on y-axis and time I am taking on x-axis. No doubt it is sine functional wave equation, but it is a negative sine functional wave equation. Therefore, you will be getting the graph like this. First trough like and then crust like, but of course it is not a wave. We are talking of the graphical representation which is looking like a wave. That is the only point. So if you take this amplitude in this particular case now becomes A omega square, that is the equation. So this is the equation for it and this is the graphical representation for it. So when you just remember wave equation along with the graphical representation, this is displacement equation, this is velocity equation, this is acceleration equation, and these three are the corresponding graphical representation for each of the equations as such. What can you infer from this data? We can understand now what is the relation between these two graphs. What is the relation between these two? And what is the relation between first one and the third one?